Hello and welcome to the Initial Load Webcast. In this video, we will go over the recent improvements to Zap's Initial Load feature. We'll start with an overview of what the Initial Load is, how it worked in previous versions, and the improvements introduced in Zap 10. When data grid instances are loaded, the initialization of the space data source component triggers loading of data from the data source into the space cache, so the application can hit the ground running with less cache misses. This takes time, and usually loads both necessary and unnecessary data into the cache. The cache is loaded with instances of needed types. These types can be specified as initial load entries in the space data source configuration, and the system will try by default to load every instance of these types available in the database. Rather than loading every available instance, the user may customize the query that the initial load uses. This query can limit the number of loaded instances or load only certain necessary instances to the cache, thereby cutting down on the load time and the waste of cache capacity. Loading instances into their routed partition may be very effective in reducing cache misses. In Zap 9, the user could customize the initial load query by overriding the initial data load method of the relevant base data source implementation. Here's an example of an override that limits the initial load to a subset of employees. As you can see, only employees whose age is over 30 are loaded into the cache at initialization time. Younger employees will have to wait their turn. The class is a subclass of the default Hibernate space data source, the Zap class for accessing a Hibernate mapped database. The user may wish to customize the query to load partition-specific data, which can improve the space performance by increasing cache hits. To achieve this, the user would need to use the routing field of the entry and data from a cluster info object to create a more elaborate query. In this example, the cluster info object is injected by Spring, and the overriding code inserts a comparison into the query that ensures only instances that belong to the current partition will be loaded. The process and customization are detailed in the documentation on Gigaspace's website. Zap 10 introduces a new and simpler mechanism for customizing an initial load process. The user can now supply custom initial load queries for entry types without the need of overriding Zap code. Of course, should the user wish it, they can still employ the old mechanism. Adding new custom initial load queries is now as simple as 1, 2, 3. To add a new initial load query, follow these steps. Write a method that returns the where clause of the query as a string. This method may receive 0 parameters or a single parameter of type cluster info. Annotate the method with a new annotation space initial load query. Finally, place the method anywhere in your codebase. Here is an example of a POJO that contains such a method. Note that this is not a subclass of any Zap class, nor does it implement any particular interface. The method extracts partition data from the cluster info parameter and uses this to create a query for the type, myClass. When the initial load process begins, the system will automatically search for these special annotated methods by recursively scanning certain base packages in the class path. The user should specify these packages in the initial load query scanning base packages property of the space data source beam definition. Here is an example of a pu.xml configuration file, and the list of base packages to scan includes a package which should include a class containing query methods. Of course, if the property is not configured, or the list is empty, no packages will be scanned. Starting with ZAP10, the system will try to optimize the loading of initial load entries by loading only partition-specific instances. In order to achieve this optimization, the system attempts to identify the routing field for the entry type and use it to construct a simple initial load query. The construction of a new query depends on the existence of a numeric routing field. The new query is executed along with the user-supplied custom queries, and other entries are loaded the same as before. This optimization is now the system's default behavior, but it can be cancelled by setting another new space data source property in the configuration, as you can see in the pu.xml example. The property value is true by default. You can read about the ZAP10 improvements in the detailed documentation on the Gigaspace's website. Let's look at a more substantial example of initial data load. In this example, we have a relational database, 3 Hibernate mapped classes, a processing unit, and a utility application that feeds data into the database. The classes APojo and BPojo are identical and contain 3 fields each: ID, name, and age. Note that the age field is the routing field for these classes. The class CPojo is an empty extension of APojo. In this class, we see an example of a class where the user can concentrate initial load query methods. Here we see 3 methods, one for each of our Pojo classes. The query for APojo will retrieve instances which correspond to the current position and current partition. The query for BPojo is designed to return all instances, while the query for CPojo is designed to return none. The processing unit configuration file specifies the connection details for the database and the mapped classes, as well as the configuration of the space data source, which includes the location of the initial load query methods. Finally, here is the code that generates instances and populates the database. These loops create 500 instances of each type and write them to the space. Instances of APojo have alternating names, while instances of BPojo are uniformly named. The age of all instances is sequential, as is the ID. To run this example, we'll first load a clean agent in the ZAP UI. The database schema is empty at this point. Once the agent is up, we can deploy our example processing unit. The PU is deployed on 2 primary and 2 backup spaces. Now we can see that empty tables were created by Hibernate. At this point, we deploy the feeder. Instances are written to the space and the database. And we can see 500 instances of each type in the database. 1,500 overall. We undeploy the feeder and the example PU. The agent is now without spaces. We will now redeploy the same example PU. This time the initial load queries have loaded 750 instances from the database. And we can see in the UI that the first partition contains 250 instances of A POJO and B POJO. And of course, no instances of C POJO. While the second partition contains only 250 instances of B POJO, having filtered out all instances of A POJO. Thank you for watching this video. You're welcome to read our detailed documentation online, or contact the Gigaspaces Support Center with any questions. Thanks for watching.